Here we've got a typical related rates question. It's a pretty entry level question. It says a spherical balloon is being inflated at a constant rate of 4 cubic meters per minute. So cubic meters is a volume. So they're telling you a dV/dt here, right? So that's a 4. Question is, at what rate is the radius expanding? So that's at what rate is the radius? So what we want to find out is dr/dt, okay? At the instant when the volume is 36 pi. And so we want dr/dt when V, or the volume, is 36 pi. So that's what we're looking at. So now what you do is you have to start with your traditional, volume of a sphere formula, right? And you're going to use this formula 2 times, all right? Once to figure out the radius when the volume is 36 pi, okay? And then you're going to use it again to figure out the rate of change of the radius and the rate of change with respect to the rate of change of the volume, okay? And as a result, you're going to end up using this formula twice. So let's go back over here. And so notice I've got volume equals 4/3 pi r cubed, okay? My volume is 36 pi, so if I plug that in, I'm going to be able to determine my radius is 3 here. So I multiply by 3, divide by 4, and I divide by a pi. These pi's cancel. I get 36 times 3 over 4, apparently is 27. And then I take the third root of that. I'm getting a radius of 3. So the radius is 3 when the volume is 36 pi. Now, over here, I know that the volume and the radius change, okay? So when now I'm going to differentiate this, all right? So some students would make a mistake is they would put the 36 pi in right here, okay? Then they would differentiate, and the derivative of 36 pi is 0, so you would get a 0 right here, okay? And then you would proceed and you would determine all of this, and you would end up losing the dV/dt, which is a 4, right? So that 4, you're going to see that 4 comes in. So remember, don't put the 36 pi in when you differentiate, all right? So now, I'm going to go ahead and differentiate. The derivative of the volume with respect to time is dV/dt. Then over here, this is 4 pi over 3. That's a constant, so it stays. Now the derivative of the radius cubed is going to be 3 radius squared. 3 radius squared. And I must now multiply by the derivative of the radius with respect to time. Now again, this is the chain rule. And so what we're doing is, remember that the radius is a function radius is a function as a function of time. And so I can't just keep the radius there. I have to multiply by the derivative of the radius as a function of time, which is this, okay? What you can kind of do is imagine that this r value isn't an actual r, it's like some kind of function with t's in it. So if you had, like, for example, something like this, 3t minus 4 squared, and I were to take the derivative of this, it would be 2, lower that to 1. I would replace the 3t minus 4, and then I would multiply by the derivative of that. So in this case, basically what I'm kind of trying to tell you here is my r here is this, and then my derivative of r is this, okay? So that's kind of the idea there. Now that I have this formula here, dr/dt is what we're actually looking for. And so there it is. It's sitting right there. So I pass all of this stuff over to the other side. I'm actually going to divide by 4 pi r squared. The 3's I canceled out, leaving me the rate of change of the volume divided by all of this stuff here. And I go ahead and I plug all that stuff in. The rate of change of the volume is 4. Remember, they told us the dV/dt up here at the beginning of the question. We also know that this is all happening at the moment that the radius is 3. And so that's why they told us the volume over there, okay? Anyway, so that's kind of the idea. Another thing that I see students sometimes do is when they differentiate this V value here, the volume, they oftentimes think that this should be a chain rule, and so they go ahead and they write the derivative of V as V times dV/dt. Now that's not the case, remember. This V should not be here. I wrote it as a mistake right now because it does not require